And we are now starting chapter 6, new chapter. We have mentioned this word before in an old chapter, probably, I don't know, first or second chapter maybe, something like that. We did mention quadrilateral. So quadrilateral is basically, oops, I got to change this setting up here. It's recording now.
I love my girlfriend.
So
She watches the video.
Bryce said he's ready to break up with you. So.
No, stop. No.
What's her name?
Emily.
Hey, Emily, how you doing?
Yeah.
Actually, it didn't.
Bryce has been cheating on you for like a year now. With some girl named Casey Chambers.
All right, got off to a terrible start. See, Bryce, see what happens? See, I play along one time and everybody goes crazy. All right, now we're really ready to start. All right, so a quadrilateral is a polygon. Remember we talked about different polygons, different sided figures and stuff like that. It's a polygon with, let's listen now. It's a polygon with what? If it's a quad, how many sides does it have? Right, with 4 sides, okay? Remember lateral? Lateral means side to side, right? In basketball, you do a lateral drill. Even in football, they probably do that. You ever do that in football where they have a ball and they blow the whistle and you go left and right and all that kind of stuff? That's called a lateral drill. And that's what lateral means, side to side. So 4 sides, all right? So it's a polygon with 4 sides. So any polygon with 4 sides is considered a quadrilateral. Now, we're going to get a lot more specific. We're going to do a whole bunch of different types of quadrilaterals, and we'll mention quite a few of them today, probably all of them today. But then as the chapter goes on, we're going to talk... As the chapter goes on, we're going to talk about more specific things about the stuff that we're talking today. Today's basically just an overview. Nico, sit right here, please. Come on. Bring your stuff. Sit right here. I'm not going to put up with it anymore. Quick, don't say anything. Just do it. Yes. Come up and get him. All right, so let's take a look, and let's put a quadrilateral up here. This is not any kind of a special quadrilateral, because we will be doing a lot of different special types of quadrilaterals, but this is just any 4-sided figure, okay? There's nothing like super special about it. I'll just make it look like this. And right there. Okay? So here's a quadrilateral. And how do I know it's a quadrilateral? It's got 4 sides. That's it. Okay? If it's got 4 sides, it's a quadrilateral. Simple as that. All right? But we're going to talk about some of the sides. All right? Each of these lengths right here is a side. By the way, we could name the quadrilateral. Let's do that first before we do what else I was going to talk about. We can name the quadrilateral. You know how we name an angle? We put that little angle symbol. We name a line segment. We put the little line segment symbol. A line, we put the arrows on all that kind of stuff. Well, there's not really a symbol for a quadrilateral. We just write quad. Okay? So I would just say quad, A, B, C, D. A, B, C, D. Oh, we had symbols for triangles too. Remember that? So that's our symbol. It's not really a symbol. We just shorten up the word quadrilateral. We just put QAD. Q-U-A-D. Everybody got it? Pretty easy. Now, but it does matter what direction we go. You can start at any point. You don't have to start at A. You don't have to start with the earliest letter in the alphabet or anything like that. You could start it with anyone, but you got to go in order. Everybody got that? So if I was going to call this quadrilateral A, B, C, D, watch. A, then B, then C, then D. Or I could have gone the other way. I could have started with A and gone which way? I could have gone A what? D, C, B. What do you think is the one way that you couldn't go? You couldn't go A to what? To C. That's correct. Okay, you got to go along the lines that A is attached to. Everybody see that?
Yes, sir.
So if I started at B, I could call this if I wanted to, and there's a whole bunch of ways that we could call this quadrilateral. But what's another way if I started at B? B, C, D, A, or I could call it B, A, D, C. It doesn't make any difference. Yeah. Nope. I just said a minute ago. There's no symbol for it. Okay. Our basically our symbol is just writing out QUAD. All right? And what else could I have called this? B what? CDA. CDA. I'm not going to write out all the different possibilities for this, but you could figure it out. What if I started at D? What would I call this quadrilateral? D what? DABC or DCBA. I just can't go what? D what? B. Okay, I can't go across. I got to go along the sides like this. Everybody got that? Yeah, that's pretty easy. Let's talk about some of the sides. Look at side AB and look at side DC. We would say that those sides are opposite. I'll just shorten it. Opposite sides. And we're going to talk about that a lot because we're going to talk about some definitions, some theorems, and all that kind of stuff. And we're going to talk about the opposite sides. So you need to know which ones are the opposite sides. Well, there's two other opposite sides as well, aren't there? What are the other two opposite sides? So let's do this. So AB, and what's the opposite side of AB? DC. Now, I'm not saying that they're equal to each other. I'm not saying they're parallel. I'm not saying anything. I'm just saying that they're opposite each other. Everybody got that? What are some other opposite sides here? Yeah, you can go DA. Let's call it AD and BC. Is that all right? It doesn't matter. You could have done it the other way as well. So AD and BC are also what? These are all opposite sides. So these are all opposite sides. Everybody got it? So this one and this one would be opposite sides to each other as well. All right? What about the sides that are next to each other? Like AB and AD. See how they connect at point A? So they're next to each other. We've had a word that we've talked about a little bit. Remember we had parallel lines cut by transversal. We had alternate interior angles. We had all that stuff. We also had another one that was consecutive interior angles. Remember that? Well, that's what this is called. So you also have consecutive sides. So AB and let's say AD would be considered what? Consecutive sides, okay? Because they have that common point where they meet right there. What are some other consecutive sides? There's also another consecutive side with AB. What's the other one with AB? AB and BC. Good. BC. So those would be consecutive sides. What are some other ones? AD and DC. So those two, this one and this one, would be consecutive sides. Again, it's important that we know this stuff because we're going to refer to this stuff later on, okay? We're going to talk about consecutive sides being maybe equal to each other or not equal to each other or something like that, all right? So we will refer to consecutive sides. I'm not going to write them all down, but these would all be considered, whoops, I will write this down. These are all considered consecutive sides, all right? So you got opposite sides, these right here, these right here. You got consecutive sides, the ones that attach, right, at one point. Do the opposite sides attach at one point? No, because AB is completely different than DC. Agreed? All right, so they're opposite sides. Then AD and AB would be consecutive sides, and so on. Yeah, it's pretty easy. Well, we talked about the sides. What else is in this quadrilateral? Not just sides. You also have what? You have angles. Do you see that? Everybody with me on that? Now, I'm going to put, I'll tell you what, let's put 2. Because I'm not saying that they're equal to each other, okay? This is just any, ordinary, random quadrilateral. So they're not equal to each other necessarily, all right? But the ones in yellow right here, what do you think we would say about those two angles? Do you think they're right next to each other? Do you think they're opposite? Do you think they're what? What do you think? They're opposite. That's right, okay? These are opposite angles. And again, both of these angles are, this angle right here, it's made up of AD and BC. Does that have anything to do with this angle down here? Does AB and AD have anything to do with angle C? Look at it. AB. Does it have anything to do with this angle C? No, I could just get rid of AB and I still get this angle C, don't I? I could get rid of, what was I going to say? AD. I could get rid of AD and I could still have this angle. You with me? So it's the two angles that are opposite each other, okay? That's what we call them. We just call them opposite angles. So instead of opposite sides, we have opposite angles. Okay, you also have, I'll do this in a different color, we also have this angle and this angle right here. Now this does not mean that these two angles right here are equal to each other. I just did it in a different color, all right? So the two blue ones are opposite, the two yellow ones are opposite. Everybody got that? Again, I'm going to repeat myself. That's fine. Later on, we're going to talk about certain types of quadrilaterals, and we're going to talk about something that's true about the opposite angles. Okay? So we're going to say the opposite angles are equal, or the opposite angles are supplementary, or whatever. Okay? Actually, we won't say that, but we do have a thing. We're going to talk about the opposite angles being equal to each other. And it's very important that you understand which ones are the opposite angles. We good? All right. So what do you think is true about the yellow one and the blue one? They're consecutive angles. Exactly right. We referred to this earlier, but do you remember when you had parallel lines and cut by a transversal? Remember this? And we said this angle and this angle. Say, what if these were parallel? What did we call these angles? We called them consecutive. I said it earlier today, actually. Interior angles. Good. These are consecutive interior angles. We did that a 3 chapters ago, whenever it was. I can't remember. All right, so we talked about consecutive angles. Everybody see that? It's the angles that are right next to each other. See how this angle and this angle have this side right here that's shared by both of them? Yeah? Okay, do you see this side right? See this transversal? It's shared by this angle and this angle. Well, look at the yellow one and the blue one. What side is shared by both of these angles right here? What side is shared by angle A and angle D? You can't.
I cannot see it.
You should have told me a long time ago. Now can you see? Is that better? All right. So what's true about, what is shared? What side is shared by both of these angles? Look, what makes this angle? These two sides? What makes this angle? These two sides. Which one is shared by both of them, Jason? Okay, side AB. That's right. Everybody see that? Look, this angle is made up by these two sides. This angle is made up by these two sides. What do they have in common? They got AD in common. All right? So that must mean they're consecutive angles. They're right next to each other. So I'm not going to write these down. You can write them down if you want. But angle A and angle D would be consecutive angles. Name me some other consecutive angles. Angle A and what else? Which one? Angle B. Right. Angle A and angle B are consecutive angles. Why? Because they have that shared side between them. You see that? So AB would be your shared side this time. You got two other consecutive angles or pairs of consecutive angles. What would they be? Jake? Angle B and angle C. That's right. Angle B and angle C are consecutive angles. They share that side right there. And give me the last set. Angle C and angle D. Right. So angle C and angle D, they would be consecutive angles as well. Again, write it down. I'm not going to write all that down just because of time, but you should be able to write while I'm talking. Oops, let me try to write that. There you go. So they would be consecutive angles. A and D, A and B would be consecutive. A and D would be consecutive. A and B, B and C, D and C. They would be all consecutive angles. Again, it's important because we're going to talk about it later on. All right, enough of that. Everybody clear on that? It's pretty easy, right? Nothing big deal. All right, so let's talk about the, how many? 5, 1, 2, 3, 4, 5. Yeah, 5 different types of quadrilaterals. And we're going to talk about these later on in the chapter. We're going to get really, really specific about these 5 things later on in the chapter. Right now, we're just telling you what they are, showing you what they look like, and maybe giving you like a little definition, okay, with all of these. Actually, you could say, no, that's right, 5. We got 5. All right, let's do this. Let's draw, oops, I don't want to draw that. I want this. So let's draw that. I'm not done with that, though, because I want to do something to it. I want to kind of tilt it a little bit. So I think if I go to transform and I go to, is it rotate or scale? I think it's scale. No, it's not scale, sorry. Let's try that again. Let's see, I go to transform and shear, I think is what I want. Yeah, let's do that. So let's go 30 degrees. That's what I want right there. I don't do that often, so. All right. Now this is still what? Quadrilateral. Why? Why is it a quadrilateral? It's got 4 sides. Okay, so it's still a quadrilateral, but it's a specific type of quadrilateral. But you don't know right now until I give you some information. So let's give you some information about this. Watch this. This side right here is parallel to this side right there. So that's one set of parallel sides. Everybody see it? What do you think might be true about this left side and this right side? They're parallel as well. So I'm going to put a double arrow there, and that represents that those are parallel to each other. So I got this set of sides that are parallel, and I got these sides that are parallel to each other. That right there is enough to tell you that this thing is a parallelogram. That's right. So it's two L's first, parallelogram. All right. Now, this is really important. We're going to talk a bunch about a parallelogram. There's a lot of things we're going to know about certain parallelograms, and really everything except for one. There's three things that are under a parallelogram. So quadrilateral is very general. What's the only thing we know about a general quadrilateral? That it's got four sides, okay? A parallelogram is also a quadrilateral, agreed, but it's a specific type of quadrilateral. It's one that has what? Well, they're not all parallel to each other. Two sets. Good. That's a good way to say it. There's two sets or two pairs of parallel sides. You see that? Two pairs of, remember the symbol for parallel? It's just that straight up and down, so I'll put that in there. Two pairs of parallel sides. And actually, not just two pairs of, what's true about the two sides that are parallel? They're what sides to each other? We just talked about it earlier. They're opposite sides. That's right. Okay? Two pairs of opposite parallel sides. Okay? So the two opposite sides are parallel to each other. We'll say it that way. Okay? So the two opposite sides, the two pairs of opposite sides are parallel to each other. That makes it a parallelogram. Okay? So it's a quadrilateral with two pairs of parallel opposite sides. That's pretty easy, right? There's more things that we're going to know about a parallelogram later on, but not right now, okay? This is just the definition. I'll put DEF. That's the definition, okay? It's a quadrilateral with two pairs of parallel opposite sides. We good? All right, let's do another one. This one you should recognize. Parallelogram. I don't know if have you talked about parallelograms before in your other math classes? Maybe like in, I don't know, 7th, 8th grade. You probably didn't do that in Algebra 1. 6th grade maybe, something like that, okay? Yeah, you probably heard this before. Who's heard of a parallelogram before? Yeah, it's a fairly common thing, all right?
So would a regular square be
We're gonna get to that. It's a good question. We are going to get to that, and this is one step closer to that. Now, watch this one. I'll just leave it like that. I'm not gonna make it slant or anything. I'm just gonna keep it like that. What do you think this possibly is?
parallel quadrilateral?
What does it kind of look like off the top of your head? What does it look like? A rectangle, yeah. But I can't say it's a rectangle just yet. Just by doing this, I can't say it's a rectangle. What do you think, just from your previous knowledge of math and elementary math, probably a little bit of middle school math, what do you think must be true in order for this to be a rectangle? All sides are equal? Does that look equal to that?
It has two pairs of opposite equal sides.
Very good. I like what Leona said. It's got four. Oh, okay. That's all right. Well, at least you listened to him. It's got four right angles. Okay, it's a quadrilateral with four right angles. Now let's talk about that. So I'm going to put a little right. We've done this before, right? Because we talked about perpendicular stuff. So there's right angles, right angles. When I first drew that thing, you couldn't really say that it was a quadrilateral. You could have guessed, a rectangle. You could have guessed that it was a rectangle, right? It would have been a good guess for sure. But you wouldn't know, because what if that angle was like 89.999 degrees? Is that 90? No. So technically it wouldn't be a rectangle, would it? Okay, but if you know all four angles are exactly 90 degrees, then you can say it's a rectangle. Now, a rectangle is also something else that we just talked about. We said it's a quadrilateral, but what else do you think it is? It's a parallelogram. How do you know that? Well, I'm glad you asked, because look, here's two lines, here's a transversal. What's true about the consecutive interior angles here? 90 and 90. They add up to what? 180. So what did we learn in another chapter about two lines cut by a transversal? And if the consecutive angles are supplementary, what must be true about the two lines? They are parallel to each other. Exactly right. So this and this must be parallel, because if these add up to 180, that must mean these two lines are parallel. Everybody got it? What about these two lines right here? And let's use this bottom one as a transversal. Well, you got the same thing. You got consecutive interior angles. They're equal to each other. That means what? That these are parallel to each other. So we know that a rectangle is actually three different things. First of all, what's the most general, the most non-specific thing? What is it? It's got four sides, so it's a quadrilateral, okay? Now we know that both pairs of opposite sides are parallel to each other, so what do we know about it? It must be now a what? Both pairs of opposite sides are parallel, so what must be true about it? It's got to be a parallelogram. And we know a little bit more specific about it. We know that they're all right angles, so now we also know that it's a rectangle. So a rectangle is basically three things. One, it's a quadrilateral. Two, it's a parallelogram. That's a long word to write. Parallelogram. And three, since it's got the right angles, what do we know it is? We know that it's a rectangle. So I'm going from the least specific to the most specific quadrilateral. Everybody got it? It's quadrilateral, four sides. It's parallelogram because both pairs of opposite sides are parallel. It's a rectangle because you've got right angles. Now, Kenzie said something about all the sides being equal. Well, that's not true about every rectangle, but if we did this, what if we did this? What does that look like it is? Looks like a square, okay? But what if this length was 7 and this length was like 7.001? Would it be a square? No, okay? But if I told you that the angles were all right angles, what could I say without a shadow of a doubt that this thing is? You could say it's a rectangle, okay? I still can't say it's a square yet because I don't know for sure it's a square because nobody told me, all right, that all the sides are equal, because that's what have to be true about a square, right? All right, so we don't know that all the sides are equal to each other, but what if I told you that all the angles were 90 degrees and all four sides were equal? Then what could I say about this thing? Now I could say it's a square, okay? Now, square, it's like everything, almost, except for the last thing we're going to talk about. It's not that. But it's about everything that we're going to talk about when we talk about quadrilaterals. So let's go to the most non-specific thing. What is this as far as the most non-specific? What is it? It's quadrilateral. Then it's parallelogram. And then it's a rectangle, right? Because it's a four-sided figure with four right angles. And then it's a what? It's a square because all the sides are equal to each other. Okay. That's a good point. I was going to bring that up. Okay, so what he said was all squares are rectangles. Every square is always a rectangle. Why do you know that? Because every square has what? Four right angles. And a rectangle has four right angles, correct? So every square is a rectangle, but every rectangle is what? It's not a square. Okay? You with me? This is a rectangle, it's not a square. Agreed? But doesn't matter how big you draw a square, it's always a rectangle. All right. We good so far? We got a couple more. Let's see how much I want to do. Oh, we do have another one. Forgot about that one. So we actually have 6. 1, 2, 3, 4, 5, 6. Yeah, we got 6 of them to do. So what are we on now? Like our third one?
That was 4.
We did parallelogram. We did rectangle. We did square. I didn't write it down. I should have written it down, shouldn't I? So that's a square. I think you could have written that down. I didn't write this. Well, yeah, I wrote it right there. It's a rectangle. That's a square. Okay? Now, if it's a square, it's all the above. So it's also a parallelogram. So if it's a parallelogram, what must be true? The opposite sides must be what? Parallel to each other. So I could do this, and I could do this. Agreed? Okay, enough of that. Let's do another one. let's draw it like this, but then I'm gonna slant it a little bit. Oops, I didn't want to do that. What did I do? Go to shear. And I don't know, let's go like 20 this time. All right. And I think I might have to pull this out just a now I don't know if this is exactly, these sides are exactly equal, but I'm trying to make them equal. Now watch. What do I have so far? What is this? What do I know for sure? I don't know it's parallelogram because I haven't marked it up yet. All right, so I don't know if those are equal or parallel to each other. I don't know. I mean, they are because of the way I did it on this program. But the opposite sides, they look parallel, but I'm not exactly sure just by this picture. What's the only thing you can say right now about this picture? It's quadrilateral. That's the only thing you can say, all right? But what if I did this? What if I said that this was equal to this side, was equal to this side, was equal to this side? Okay? So all the sides are equal. Does that make it a square? No, it's not a square unless what? What was true about the angles? All the angles were 90 degrees. Okay, so I can't say it's a square, but it does have all four sides equal to each other. This is a quadrilateral. It's a four-sided figure that you probably haven't heard a whole lot about. Parallelogram is probably one of them. You might have heard the word, but you didn't really know anything about it, right? And this is another one. So this is called a rhombus. It's RH. I don't know why they stick the H in there. Maybe it's rhombus. Rhombus. I don't know where that came from. I've never looked it up. But anyway, it's called a rhombus. We just say rhombus. All right, so we just say rhombus. But a rhombus is a quadrilateral. So what's the definition? It's a quadrilateral. Let's put a little space in here. It's a quadrilateral with what? Four. Well, we didn't say anything about being parallel. What did we say about the sides? They're equal, right? Four equal or congruent sides. Okay, so all four sides have got to be equal to each other. All right. We are going to talk about a rhombus a little bit later. We're going to get a little bit more specific with it. And you will find out that a rhombus does have both pairs of opposite sides parallel to each other. Okay? Everybody hear me? We're going to talk more about that later. But right now, all we know is a rhombus is just a quadrilateral with four equal sides. But we will find out later that these sides are parallel and these two sides are parallel. And we're going to learn a bunch of other stuff about a rhombus, okay? You wouldn't believe how much stuff that we could know about this little four-sided figure, all right? But there's a bunch of stuff that you can know about it. All right, here's another one. Everybody got all that so far? We have time to do two more, so we got two more to do. So this one's going to look quite a bit different. I'll try to make this as exact as I can. So we'll see. Just bear with me on this. So I'm going to do this. I'm going to copy and paste it. And I think I can transform and I can reflect. There we go. That's what I want.
Do all the angles in a quadrilateral?
That's not what I want. I forgot to hit OK. Say that again.
So all the angles in a quadrilateral would add up to 360, right?
They would. We're going to get to that eventually.
Because you cut it in half in the triangle.
What did I say? Reflect. Then I hit OK. All right, let's take a look. Guys, just because I'm drawing this doesn't mean you start your own little conversations. We've talked about this 100 times. So watch, I'm going to take that, put it right there. I'm going to take this and put it right there. Okay. Looks like a what? A kite. Are you crazy?
It looks like a kite.
It is a kite. All right. It's exactly what it is. And geometrically, all right, even in geometry, that's exactly what we call it. It does look like a kite because it is a kite. I could have rotated it. I could have rotated it up if I wanted to, but we're just going to keep it like that. Now, here's what's true about a kite. Does it look like, just by looking at the picture, okay, does it look like you have parallel sides here? It does?
It intersects on the thing.
Yeah, they all intersect each other. Okay, so this intersects this, it intersects this. Okay, and eventually this one and this one would intersect as well. All right, but you have no parallel sides. But here's something you have to do. I don't know if you were watching when I was drawing this thing, but I took this side and then I didn't just flip it, but I made a new one. So what did I do to it? I copied it. I copied and pasted. So you guys are losing me. Come on. So I copied this, pasted it, and all I did was kind of rotate it so it went in this direction. And so what must be true about the length of this one and this one? If I copied and paste, they're the same, right? So this one and this one are equal to each other. Now, I didn't copy and paste this. I just drew it like this. But I'll tell you right now, this one and this one are equal to each other. We'll talk about that. Yeah, we're going to talk about that later. We will talk about that, okay? So, Jason, which angles? This one and this one? Nah, not those. This one. Yeah, the top and bottom ones. Yeah. Okay. I thought you meant sideways like this. So we're going to talk about this later. Shh. Come on now. Still got 5 minutes, so hang on. Give me 5 minutes, okay? So look, today we're not really talking about this, but eventually we are, okay? That this angle right here will be equal to this angle right here. But right now we're just talking about the definition of a kite. So here's the definition of a kite. It's really long-winded. Let me read it to you real quick, but then I'll just explain it to you. It says, a kite is a quadrilateral with two pairs of equal consecutive sides. All right? Two pairs of equal consecutive sides. So look at this side right here and this one right here. They're consecutive sides, aren't they? Remember we talked about that right at the beginning? They're consecutive, and they're equal to each other. So that's one pair. So if the other two sides, consecutive sides, are equal to each other as well, then you have a what? Then you have a kite. But what has to be true is all four of them can't be equal to each other. Because if all four were equal to each other, then it would be a what? No, not necessarily. No, a rhombus. A rhombus, okay? So this has exactly two pairs of congruent or equal sides, okay? Again, we're going to talk about a whole bunch of other stuff later on, but that's like our fifth one. One more, and then we'll be done. You might have seen this before. It's not the same as a rectangle.
It's the opposite.
Doesn't have right angles. It is. All right, let's take a look at this. Right now, just by looking at the picture, what is this? It's quadrilateral, because I don't know anything about it, right? All I know is that I got four equal sides. You done already? Is that your attention span? Is it done? Has it reached its limit? So look, right now, all I know is it's a quadrilateral, okay? But if I knew this, if I knew that this side and this side were parallel to each other, now I can say this is a special name, all right? And Bryce already said it. It's a trapezoid. Okay? It's called a trapezoid. So what is a trapezoid? A trapezoid, listen, it's a four-sided figure. It's a quadrilateral with exactly one pair of parallel sides. What does that mean about the other two sides? It means they're not parallel. So if it says exactly, seriously, it doesn't matter. It doesn't matter. Oh, my word.
You were doing so good. The whole
I got one more. It was a trapezoid. Let me just do this. I don't have time. I'll after the bell rings, I'll talk to you. Now watch this. What is this? This is a what? It's a trapezoid. But now watch. Here's one. Don't leave. No. You wasted my time. I'm keeping you. Sit down. So watch. So this is a trapezoid, but this is a little different than the other one. This side and this side are equal to each other. We've used this word with triangles. Remember you had a triangle with two equal sides? What do we call it? It starts with an I, isosceles. So this, what do you think this is called? This is called an isosceles trapezoid. Now you can go.